Let's understand what machine learning can and cannot do in this one. We will try to clear out some of the misconceptions that are commonly existing amongst the folks that you're going to be working with. Right. So when you're working on a machine learning project, be it clients that you're working with, or be it executives if you're working with an organization, amongst the various stakeholders that you are working with, it is common to have unrealistic expectations about what AI and ML can and cannot do. And one of the reasons for this is the media and the blogs and the news channel, of course, right? Most of the successful use cases of what ML was able to do is very widely publicized, whereas the unsuccessful cases and what sort of data is required to make a successful case a success is not really reported. So naturally, a lot of people tend to believe that AI and ML can do things automatically, and which is unfortunately not really the case. Now let's understand this a bit more closely by taking the example of demand forecasting example, demand forecasting for commercial products to be more precise. Now, demand forecasting is a classic example of implementing a data science project on something that is very important for the company. Traditionally, for companies that are traditionally doing demand forecasting, they would typically have human experts who are really good at what they're forecasting. They tend to have human experts who do the forecasting manually, and they tend to have a really good understanding of the field or the product and the domain at which they are doing the forecasting. Now, when you want to improve the accuracies of the human created forecast, it is now becoming popular for companies to adopt AI and machine learning to do the forecasting and to do the forecasting more accurately than what a human can. Now, in this situation, businesses tend to have an expectation that ML can independently produce the forecast without the interference of a human expert or a domain specialist in this case. Now, I'm not saying that it is not possible to get fairly accurate forecasts for predictable items. For example, if you want to forecast what is going to be the demand for newspapers on a daily basis, such a task can be actually trivial and easy. You can actually achieve fairly good accuracy for something that is so predictable as newspaper demand. Whereas when it comes to commercial products, such as say the electric cars or heavy machinery or electronic goods or even certain category of FMCG goods, it might be really hard without providing the insights and inputs from domain experts. Why I say this is because once you deploy your forecasting solution, forecasting machine learning model, as you start using the model on a day-to-day basis or month-on-month basis, you will see that certain points in time the model is going to produce unrealistic or incorrect forecasts, right? Those inaccuracies does not often mean that the model has gone wrong. It might not be the case. If an inaccuracy is observed, it can be due to various different reasons that the domain experts, the domain specialists in the respective field can come and answer that for you. For example, an inaccurate forecast can be due to various reasons. Maybe there was a product launch from the competitor, right? That could be a reason. Maybe there is a government legislation, or it could be seasonal factors like people receiving income tax returns at certain point in the year, and that in turn could spurt more sales for a certain segment of population. So there are so many reasons that needs to be understood when you are doing a project on demand forecasting, right? For this, you definitely need a human expert to provide the necessary insights so that you are able to correct your forecast that the machine learning model is able to provide. In due course of time, you can model your ML algorithm such a way that it can learn such repetitive factors that keep happening over time. But the point is, the AI in this case is not independently capable of learning everything that is happening on the field. That would be an unrealistic expectation. Now, the second point is setting an unrealistic expectation about the accuracy that your ML model can achieve even before getting started. The level of accuracy that you can achieve on a demand forecasting actually depends on the nature of the series that you're trying to forecast itself, the nature of the economic situations and various market conditions that exist that could in turn influence the future forecasts. It also depends on the quality of the data that is supposed to explain the series that you're trying to forecast itself. Let's take one more example. Let's suppose you are building an automatic response system for your customer support team, and your objective is your response system should be able to respond back to the large number of or large volumes of customer support queries or the emails that are coming in. So what you want to do is build an ML driven automatic responder that replies to the customer incoming customer emails or any sort of queries, right? Now to do this, you might be able to answer all the emails with a standard thank you email. But this is very generic. It's not serving much of a purpose. Now, if your stakeholder is coming back and telling you that, okay, I don't want to send a very generic email, whereas I want to send more meaningful emails back to the customer so that it reduces the number of touch points or interchanges between the customer and the agent who is going to attend them. That would in turn free up the valuable time of numerous customer service agents. That's a great advantage to it. Also, it should also help with improving the customer satisfaction and getting the very first response back in a very short period of time. Now, instead of responding back with a very customized query, say as a response to a customer, if you want to send a response like, "Hey John, hope you enjoyed the game yesterday with your kid." This sort of a response is highly customized. The AI has no way of knowing about these things. Like this is a highly customized response, which probably a human will be able to do very easily, but for an AI, it's very difficult. So what you can alternately do instead is, instead of setting an expectation that the AI is going to respond back with a very customized response, instead of doing that, what you can instead do is you can build a system that gets the user query as an input. You get an input which is nothing but the text of the user query. Then identify the intent behind that query. We generally call it as the reason code. You identify the reason of why the customer is contacting you. You identify the reason code, and for each reason code, you can create a customized, curated response. There can be numerous intents behind it and groups and subgroups of intents behind a given intent. Say a typical popular intent is a customer would want to get a refund. Within refund, he could go for either a trade-in, exchange, or it could also be an outright cashback. Various different sub reasons could be there within a given reason code. What you can do is you can work with the domain experts. You can work with the experts within the existing customer support, work with them and curate your set of own responses that they would want to send back to the customers. And that could be a practical, workable, and a more predictable solution that the agents and the company can benefit from and be able to control what they are actually responding back to the users. So, for the success of building such a system, you need to set the expectation right and clear out all the misconceptions behind what ML can and cannot do.